All right. So today our lesson is about isosceles and equilateral triangles. We're getting really specific with the types of triangles we're looking at today. Let's see, today is November 1st. We have 2.5 weeks until the end of the trimester. There will be one more unit test. We're gonna have a unit test on unit 4. There will not be a final exam. Okay, so we're not going to do an exam that covers everything we've done. The last exam will be probably the Tuesday of the last week of the trimester. The last unit test will be on the Tuesday of the last week of the trimester. That will allow us to finish the test, make corrections to the test on the last 3 days. Because once those last days are up, like that's it. There's nothing that next week that you'll be allowed to do anything for to make your grade any better. So those last 3 days are going to be used for test corrections, finishing tests, old stuff, whatever you need to do. All right. So there we go. Parts of an isosceles triangle. The two congruent sides of an isosceles triangle are called the legs. So right here, that's a leg. And right here, that's a leg. The two congruent sides are called the legs. The angle where the sides intersect, where the congruent sides intersect, not just the sides, the congruent sides intersect, is called the vertex angle. So right here, angle number 1, that is the vertex. There? Only there. So where the two congruent sides meet is the vertex angle. So angle 1 here is the vertex. The side opposite the vertex angle, what that means is if you look where B is, or 1, that's the vertex angle. If you look straight across, this side right here, AC, side AC is called the base. So the base length is that right there. So AB is a leg, BC is a leg, AC is the base. Those are the sides. In terms of the angles, angle 1 is the vertex, and then angles 2 and 3 are both base angles. So angle 2 is a base angle, and angle 3 is also a base angle. So those are the different parts of an isosceles triangle. So your vertex is where the two congruent sides meet. The other two angles are the base angles.
But what are they all vertex?
So this should be more specific here. It's the angle where the congruent, that should say congruent right there. The angles where the congruent sides intersect is called the vertex angle. Yeah, they left out a word there or a symbol. It's where the congruent sides meet. Now, it doesn't necessarily have to be at the top, because you could draw an isosceles triangle sideways. So it's not always going to be the top of the triangle. It's where the two congruent sides meet. So like let's just look at number 2 real quick. Number 2, the vertex angle would be D at 106 degrees, because that congruent side and that congruent side meet right here. So that would be the vertex.
For 3 would be Y.
For 3, it would be Y, exactly. Yeah. So wherever the congruent sides meet is the vertex. All right. Heading back to some words here. We got the isosceles triangle theorem. This is something that some of you might have figured out already, but if you hadn't, it's a pretty easy thing to learn. It says, if two sides of a triangle are congruent, listen up. If two sides of a triangle are congruent, which we have, meaning if it's an isosceles triangle, right? Two congruent sides means isosceles. Then the angles opposite those sides are congruent. That would mean if you look across from this length here and you go across, that would be angle 3. If you look across from the other congruent leg over here, that would be angle 2. So what we're saying is, if you have an isosceles triangle, then the base angles are congruent. So what we're going to say for this, we'll look for an example. How do we want to write that? Just going to check in on something real quick, make sure. Sometimes I'm not a huge fan of the examples that they give, so I'm just going to double check, see if I like it. Yeah, we'll use this example up here. So our example is going to say if AB is equal to, or if AB is congruent, segment AB is congruent to segment BC, then AB, yep. So if the length of AB is congruent to the length of BC, which it shows is true up here, then angle 2 is congruent to angle 3. Exactly. Yeah. Okay. So the easier way to think of this, real quick, the other way to think of this is, I'm just going to write it off this side. If isosceles, then base angles are congruent. That would be the easier way of writing that theorem. The theorem itself is true, but it's a little, I don't know, it's a little, not a little, it's very specifically, like technically written. This is a little bit less technical, and I think it makes a little bit more sense. So if two sides of a triangle are congruent, that right there means you have an isosceles triangle. So we're going to say if you have an isosceles triangle. Then the angles opposite those sides are congruent. Well, the angles opposite the sides that are congruent in an isosceles triangle are called the base angles. So I would rather just say that. So if you have an isosceles triangle, then the base angles are going to be congruent. All right. Angles.
Oh.
That's an S. Yeah, angles. Then base angles. No, my S's are sometimes a little angular. So angles. The apostrophe. All right. So if isosceles, then base angles are congruent. Okay. The next one says exactly the opposite. Converse, if you remember from last week, means you just switch the phrasing around. So if you have two angles that are congruent, then the two sides opposite of that would also be congruent. So off to the side here, let's say if two congruent angles, then the triangle, this is for the bottom one. If two congruent angles, so if you have two congruent angles in a triangle, then the triangle is isosceles. So it's the converse. Now, we're not going to say if the two base angles are congruent because we don't know it's isosceles yet. You can only call them base angles once you know it's isosceles. So if you have two congruent angles, that automatically means that you have an isosceles triangle. And so our example is going to say, if angle 2 is congruent to angle 3, then side length AB is congruent to side length BC, or segments. So we're just switching the phrasing because that's what a converse does. All right. So for the rest of this lesson, the math is going to look exactly like what we did yesterday. Except it's going to be more specific because we're only dealing with isosceles for the first part. And then at the very end, we'll talk about equilateral. So here we go. Let's take a look. Does anybody need more time on this? Writing this down? Okay, I'll leave that up there for a little bit longer then. Oh, I should probably just go ahead and do attendance while people are getting this written. Let's see. Arlexi? No? All right. Adele's here. Ralph is here. Jackie? No? Nancy, Savannah,
Jackie not here?
Jack. No. Aiden. No. Oh wow. No. Caitlin. Okay. 3, 6. All right. All right. Let's go ahead and start working on some of the math here. So problem number one, we have an isosceles triangle, which automatically means that angle L is congruent to angle J. Those are the base angles, which means they have to be congruent. So that means that angle J is automatically how many degrees? 68, exactly. So measure of angle J, 68 degrees because it's congruent. It's a base angle. Now we have two of the three angles in the triangle. Ready, Rob, you paying attention? Yeah. Don't do that right now. Do that later. We're doing math right now. All right. So 68, 68, what's the vertex? How many degrees is the vertex? Yeah.
How do you know?
Well, if this angle, so we have isosceles triangle, right? So this angle, I'll explain it, Rob. It's all right. 68 here. That one also has to be 68. Triangles add up to 180. So if two of the angles are each 68, take them both away from 180, and you're left with 44. So 68 plus 68, and then take that away from 180, and use what we used yesterday, the triangle angle sum theorem. All right. Number two. Which ones are congruent on this one? C and E. All right. So whatever we get for one of them, we get for the other. All right. I'm going to just go ahead and ask, what do you think those are each equal to?
37.
Why? Yep.
And we know that E is 106.
Yep.
So I take away 106 from 180.
Yep.
And then you divide that by 2.
Exactly. So what Rob was saying is that this angle is 106. Okay. As up here, guys. This one's 106. So if we take this away from 180, that tells us what those two add up to, because that's what's left over in the 180 degrees, which is 74. So both of those together equal 74 degrees, because we took 106 away from 180. And we know that those have to be the same because it's isosceles. So if you take 74 and you split it in half, divided by 2, you get 30, what was it? 37?
37.
37, there you go. So each of those angles, C and E, 37 degrees. Nice. Now, number 3 is a little bit different. Yeah, we have to figure out the measure of angle Y, but it's also telling us to find the length of YZ. So I'm going to put a couple markings on here. We know that X and Z are congruent. It shows us the numbers for that, but the side lengths here are also congruent. So if YX is 12 centimeters, how long is YZ? 12 centimeters, yeah, because those side lengths are congruent. Notice here, this is not an angle measurement. This is a side length. No, 2 of them are. 2 of the sides will be the same. 2 of the angles will be the same. Right now, we have both angles that are the same. So we need to figure out the vertex here. So how many degrees is the vertex angle at Y? Angle Y is how many degrees? And we're no longer just dealing with angles, we're dealing with both side lengths and angles. So how many degrees is angle Y? What is it?
Oh, it's 26.
26, yeah.
Wow.
26 degrees. So each of the base angles down here is 77 degrees. So if you add those up and take them away from 180, that gives you the measure of angle Y. So there's going to be 2 kinds of math that we're doing here. We're going to be figuring out the angle measurements like we did yesterday, but we're also going to expand this to some side lengths, depending on what we're looking at. So let's move on to number 4. So problem number 4, are we trying to figure out, it's always a good idea to figure this out before you start the problem. Are we figuring out angles or are we figuring out side lengths on number 4? Where are the arrows pointing to?
Angle.
Angles. What do we know about those 2 angles? Yeah, they're congruent. Those are the base angles. Base angles are congruent. So our equation will be 5x plus 9 equals 8x minus 30. If I was doing this one on my own, I would actually write 8x minus 30 equals 5x plus 9 because I like to have the larger value of the variable on the left, but this is fine. So I'm going to subtract 5x from both sides. So minus 5x, and that'll give me 9 equals, let's see, 3x minus 30. And then we can go ahead and add 30 to both sides. So plus 30, and that's 39 equals 3x. And nicely enough, 39 is divisible by 3. What's 39 divided by 3? Yeah, x equals 13. So all we have to do here is find the value of the variable. We don't need to plug it back in and find an angle measurement. Some of the problems might have us do that, but we're not doing that yet. All right, same thing for 5. I want you to do that one on your own real quick. Hey, just work on number 5. Number 5. Same setup as number 4.
Does it matter which one we put in first?
No, it does not. As long as you set them equal to each other and you solve for x, you're good to go. All right, if you want to check your work, take a look. Any questions on number 5? X equals 8. You got a decimal. What equation? Did you write this equation here? 9x minus 33 equals 4x plus 7, or 4x plus 7 equals 9x minus 33. All right. So that's it for number 5 there. X is equal to 8. Any questions? Any other questions? Okay. Now, with 6 and 7, real quick, with these ones down here, are we trying to figure out side lengths or angles on this one? Side lengths, yeah. Now, the thing about it, though, is that the math that we're doing here isn't any different than what we just did. So this time on number 6, our base angles are here, which means that the congruent sides are these two. And so the math is identical to what we just did. We're going to set these two things equal to each other and solve for x. So there's no difference in terms of how these set up and how they're solved. So here we go. 23x minus 17 equals 15x plus 7. We'll go ahead and subtract 15x from both sides. What do we get here? What's 23 minus 15? 23 minus 15.
Well, but 8.
8, yeah, all right. So 8x minus 17 equals 7. Add 17 to both sides. What's 17 plus 7? Mm-hmm. 24 divided by 8. X equals 3. Good. So number 6, x is 3. 7, exact same idea. In fact, I'm not even going to do number 7. We can skip that one. Those two right there are congruent to each other. You would set them equal, solve for x. It's not any different. All 4 of these problems are the same. Question, Madison? Which one? Yeah. All right, we're skipping number 7. Go ahead and flip it over to the back. All right, so on the back, we got 3 more questions with isosceles triangles, and then we're going to finish up with some equilateral triangles. So here we go. Number 8, this one does not show us the triangle. What should we do?
Make one.
Draw it. Yes. All right, now, in terms of how you draw these need to be a lot more specific than the ones that we did yesterday, because these are not any generic triangles. These are isosceles. So we need to be really careful about how we draw these ones versus yesterday where it didn't really matter. But what you can start with is you can start with any isosceles looking type of triangle like that. So make it look isosceles. And then from there, it really matters where we put our vertex. So I want you to look at this statement right here. Segment RT is congruent to segment ST. Who thinks they know the vertex angle here? And why? It's actually not going to be S. Nancy, why do you think it's T? It's a common point between those two, yeah? So when you are looking at trying to make your isosceles triangle on the diagram, the vertex angle will always be the one that is the same letter between the two sides that are congruent. So T and T, that means that T is the vertex because those two side lengths meet at point T. So T goes up here as our vertex, and then R and S can be either one of those. Once you get your vertex angle, it doesn't matter where the other two go. So I'm going to put R here, and I'll put S there. Now it told us that RT is congruent to ST. So there we go. RT is congruent to ST, which also means that which of the two angles are congruent? Yeah, R and S are congruent because those are the base angles. Now, in terms of what we are being told after these two side lengths are congruent, is the rest of it dealing with side lengths or angle measurements? Read the rest of this problem. Are these sides or are these angles? What does this say? Measure of what? Angle. Okay, so we're talking about angles. So, measure of angle R is 9x plus 2. The measure of angle S is 13x minus 8. The measure of angle T is 17x plus 1. So yeah, there's actually 2 ways to do this one. We could just do what we did yesterday, where you add all 3 of them together and set them equal to 180. That would work because we know that has to be true because it's a triangle. You could do that to solve for x, just like we did yesterday. Or, because we know those 2 are equal to each other, we could set those 2 equal to each other here and solve for x. Either way, you'll get the same value of x because both things are true. Those 2 are equal to each other and all 3 of them add up to equal 180. So you have an option in terms of how you want to set this one up. I'm going to set these 2 equal to each other because I feel like it'll take a little bit less time. So I'm going to write 13x minus 18 equals 9x plus 2. I'm putting the angle S first because I like my larger variables on the left because they stay positive if I keep them on the left with the larger ones on the left. So let's see, we'll subtract 9x from both sides. And the rest of this problem is exactly like what we did yesterday. We get x, we plug it in, we figure out the angles. All right, so 13 minus 9 is going to be 4. So that's 4x minus 18 equals 2. We'll add 18 to both sides. 18 plus 2 is 20. So 4x equals 20. Divide by 4. What's 20 divided by 4? 5. X equals 5. So off to the right, write 5 for x. All right, now plug x back into all 3 angles. Once you have x, plug it in. What's 9 times 5? 45. What's 45 plus 2? 47. So the measure of angle R is 47 degrees. Now, that is one of the 2 congruent angles. So when we plug x in for S, when we plug 5 in for x here, we should get the same number when we do the math. So let's see, 5 times 13 is Could be 65. 65 minus 18. 47. There we go. That right there is a clue that we're doing this correctly. Two of the angles are the same.
So did we do 13?
We did 13x minus 18 equals 9x plus 2 to solve for x. Because those two angles were the same, so we just set them equal to each other here. Just plug x back in to up here. Yeah. Uh-huh. And then 17 times 5 plus 1. 17 times 5 is 85 plus 1 more is 86. All right. Now, if we add all three of those together, what number should we get? 180, because it's a triangle. So if you add those three together, that's another way to check to make sure you did this correctly. So you have multiple ways to very quickly check to make sure you've done these right. All right, let's move on. Next one says in triangle DEF, angle D is congruent to angle E. So once again, we're not starting with congruent sides this time, we're starting with congruent angles. So if you draw an isosceles looking triangle, which angles look like they're about the same? Out of those three, which two look like they're about the same? Right, but in terms of the look of this triangle, because we don't have any letters yet, the ones on the bottom, right? The two angles on the bottom look like they're about the same, so that will have to be D and E. It doesn't matter which one's D or E, but the two on the bottom are D and E. What's that? So the vertex is the one that isn't congruent. So like D is congruent to E, which would be the two at the base. So F has to be the one at the top. You got it. So whichever one's left over, that's your vertex. And you'll notice this time, we're not starting with side lengths congruent, we're starting with angles congruent. But because these two angles are congruent, those two sides are congruent. Makes it isosceles. Now, if you read the rest of this problem, take a look. DE is equal to x plus 4, EF is equal to 4x minus 8, DF is equal to 7x minus 35. Do we have the angle symbol anywhere here? No. So are we talking about angles or side lengths? Side lengths. So if we are going to solve for x, listen carefully. We cannot, I can't make this any more clear than what I'm about to say. We cannot add these three things together and set them equal to 180 because those are not angles. Those are side lengths. The only way we can solve for x here is to set those two sides equal to one another. And we know that DF right here is 7x minus 35. And EF over here is 4x minus 8. Those are the two that we have to set equal to each other to solve for x. DE, we'll use that later. We'll plug in for x once we have x. We are not going to use this to figure out what x equals, though. So 7x minus 35 equals 4x minus 8. So subtract 4x from both sides, minus 4x minus 4x. 3x minus 35 equals negative 8. That is a negative 8 because there was a minus there. What's negative 8 plus 35? Okay, so 3x equals 27. Divide by 3, what does x equal? Should be 9, right? 27 divided by 3 is 9. So x equals 9. Now we have to find the length of each side. When it says the measure of each side, it just means the length. So DE, that's this one here, x plus 4, which is 9 plus 4, which is 13. Now EF and DF have to be what? They need to be equal to each other. So whatever you plug in for x here and here, those numbers better end up being the same length. If they're not, then it's not isosceles, but it is isosceles. So if you don't get the same numbers for those two, then something didn't go right. So let's take a look. For EF, that's this one here. 9 times 4 is 36. 36 minus 8 is 28. All right, so EF is 28. 9 times 7 is 63. 63 minus 35. 28. All right. Cool. So those are those examples that you're going to see as well. Skip number 10. Skip number 10. We're going to finish this up real quick at the bottom here with equilateral triangles. All right. Here's something that some of you probably were thinking was true, and today you're going to learn that it is in fact true. So, first of all, triangle is equilateral, meaning all three sides are the same. If and only if it is, here's what it says. A triangle is equilateral if and only if it is what? Equiangular. So if you have an equilateral triangle, that automatically means that all three angles are the same. If you have a triangle where all three angles are the same, that automatically means that all three sides are the same. The two are interconnected and cannot be taken apart. 3 equal sides means 3 equal angles. 3 equal angles means 3 equal sides. There is no getting around that. So no matter what, those two things have to be true if one of them is true. So all the sides are the same. All the angles are also the same. So what we're going to say here is if the measure of angle B is equal to the measure of angle A and C, they're all the same. That means the result is right here. AB, write this down. AB equals BC equals AC. That's the result. If all the angles are the same, all the sides are the same. If all the sides are the same, all the angles are the same. So measure of angle A equals the measure of angle B equals the measure of angle C. And right underneath here, I'm going to put another dot because we're going to write in something else. Each angle is equal to what? Who can tell me that? If you have a triangle and all three angles are the same, automatically you know what each angle measurement is if it's equilateral. Close? 60. Yeah. Is equal to 60 degrees. Every single angle, listen up. In an equilateral triangle, no matter what, each angle is equal to 60 degrees. Because the three of them add up to 180, the three of them are equal to each other. So 180 divided by 3 is 60. Every single angle in an equilateral triangle is 60 degrees, no matter what. The lengths could be different, but the angles will be 60. So, number 11, take a look. They add up to 180. The three angles add up to 180, but each individual angle has to be 60 because you're cutting it 3 ways and they're all the same. So on number 11, how many degrees is angle C? 60. It has to be 60. Every angle is 60 degrees in an equilateral. All the sides are the same. So if AB is 9 feet, what's the length of BC? 9 feet. What's the length of AC? 9 feet. All the sides are the same. All the angles are the same. Number 12. What's the measure of each angle? 60. Yeah. All three of them are 60 degrees because it's equilateral. There's no getting around that. All right, number 13. Number 13. Let's figure out the measure of angle R. How many degrees is the measure of angle R? 60. So to figure out x, listen up, figure out x, 7x minus 3 equals 60 because every angle is 60 degrees in an equilateral. So 7x minus 3 equals 60. Add 3 to both sides, 7x. What's that?
Why are we different?
What do you mean? What do you mean by that? Which number are you talking about right now? Number 13? Okay. So right now we're just dealing with the angle. So the angle has to be 60 degrees, so we can solve for x by setting it equal to 60. And you're asking about the side lengths? Okay. So the side lengths are also all the same length. So that one's equal to that one, which is equal to that one. So all we have to do to solve for y is pick 2 of those and put them equal to each other, because all 3 of them are the same. So any 2 of them set equal would get us the value of y. Usually what I do in this case, we actually solve problems like this in lesson 4.1. Usually what I do in this case is I'll take the 2 lengths that have the smaller numbers and put those equal to each other. So I'm just going to put that one equal to that one to solve for y. So I'm going to say 11y minus 23 equals 9y plus 1. And then solve for y. So I'm going to subtract 9y from both sides. That would be 2y minus 23 equals 1. And we can add 23 to both sides. That would be 2y equals 24. And then divide by 2, 24 divided by 2 means that y equals 12. So x equals 9, y equals 12. All right. Perfect timing. We will go over the answers to this first thing tomorrow. I'll take questions on the first 3 lessons as well. Then we'll do our partner quiz for the rest of class tomorrow.